Cool. Okay, so before we start, just as a reminder about my color code, if you guys want to title this as what ion we're doing, you can put it. All right, any year 12s? You guys were here all last week on Friday? If you don't have a picture, you need a picture. Okay. Rightio. So, in order to help keep track of the various ions that I'm identifying, I'm going to write at the top, this is your teacher example. You guys can then, when you're doing your unknowns, do unknown number 1, unknown number 2, unknown number 3, unknown number 4, so that way you're keeping track of which ones you've done. All right, so this is the teacher cat ion example. And just as a reminder of my color code, the yellow tends to be for processing, or not tends to. The yellow is processing. So with that, it's not that it's something that I'm expecting you to write on the assessment. It's just notes to help you understand how I pulled information out. If you see something in red, that is the achieved. If you see me write in blue, then that's the merit level material, and if you see me writing in green, that's the excellence level material. Really useful when you guys are checking my notes to kind of understand what you need to do at the different levels. And it gives you an exemplar. All right, so we are now looking at the cation flow chart. So very different looking flow chart to the anion, much, much longer because we have far more ions that we can identify with this flow chart. When I'm looking at my steps, the first step in this case is to add the 2 drops of sodium hydroxide. It is really important that you only add 2 drops because when you look later in our flow chart, some of them have the option of adding excess. So really key that you're just doing the 2 drops first and then you're saturating it to see if you can form a complex ion. So let's write that as my first step over there. So my experimental procedure, what I'm going to do is take my unknown and add 2 drops of sodium hydroxide, NaOH, and state our observations. So here's my test tube. I am grabbing the unknown that I want us to identify today for my example. Whoops, sorry, can't see it. Now the trick with a lot of this is it's just going to be about getting the right ratios when it comes to those ions, so that's why I suggest double and triple check if you're not sure. There's a lot of tricky ones that are white precipitates that look very similar to each other, so it's worth double checking stuff. So that's my unknown solution. I am grabbing my sodium hydroxide, which is this guy over here. Again, if you're not sure about formulas and names of stuff and how to translate the 2, look at the bottles because the bottles have them labeled both ways. I just want to add 2 drops of that, so that's what I'm going to do right now. Very kind of gently 1, 2, and then mix it together. And what do we see? White precipitate. Is that, white precipitate is what we want. So that's my observation. We have a white precipitate forms. We're good so far. All right. Now, when I look at my flow chart, it says add excess sodium hydroxide into my solution. So we're going to use the same sample, the same test tube. So to the same test tube, whoops. Excess NaOH is added. So remember, for the achieved, I need to see all your experimental procedures. So here is my original test tube that I was doing. Here's my sodium hydroxide, and I'm going to saturate it with a lot of sodium hydroxide, and we'll notice now that it's gone colorless. So my precipitate has disappeared. So white PPP disappears. And we'll also make the observation on the solution. Solution is colorless. Is now colorless. We can even add more descriptive. Are you okay with that so far? Questions, concerns, comments? Good? All right. So based off of that flow chart, we have done that 2 drops. We've had a white precipitate. From that white precipitate, I have added my excess sodium hydroxide, and since my precipitate has disappeared, I've now narrowed it down to 3 potential ions, aluminium, zinc, and lead. Cool? What did I want to say about that? I can't remember now. Hopefully it'll come to me. If not, maybe not. All right. Next thing I then do is I take a new sample, and we're going to do the same thing again, but in this case, we are doing it with ammonia. Be mindful, it says 2 drops, then excess. I would treat this as 2 steps. So when I write it up on my sheet, I'm going to write it up as 2 steps. So first thing I'm going to do is take my unknown. So we have a new sample. We take the unknown and add 2 drops of ammonia in this case. So that's NH3. Sorry, let me zoom out so you guys can actually see the whole thing. There we go. All right, new test tube, grab my unknown. Again, remember about those ratios. You just want a little bit, but not too much, because then you're going to make a lot of precipitate and it's going to be hard to dissolve it. All right, here's my ammonia. Again, colorless solution. Carefully add the 2 drops. You see a precipitate form, just like we did last time. So we're going to go make that note. White precipitate forms. Then to the same sample, we're going to add excess. If I look at the list, add 2 drops, then excess ammonia. All right, so here's my ammonia, here's my original sample. Again, we're going to do a nice big squirt, and we're trying to see if that precipitate disappears. And in fact, it didn't disappear, it got whiter. If I want to double and triple check things, you are more than welcome to do things again. But the thing that I find really helpful to me is I go grab a pipette, and I just want to double check that I had the ratios correct, so that way I am actually diluting it. I'm going to grab a few because I want to show you guys what another precipitate would do, just so you guys know what you're looking for. So I'm just going to take a little bit of that out of my test tube, if I can get it out. Okay, that's annoying. Let's try to get it into this test tube. Just going to pour it now, I guess. There we go. So I got a little bit less in here now. Again, I'm just testing out to see if I get the ratios right. So getting some more ammonia in there, and we see that it's still not getting rid of it. So I'm very confident in this case that it's not dissolving. So I would say the precipitate remains. So from that information, when I'm looking at my flow chart here, since that precipitate remains, I'm going down this way, and I've narrowed it down to aluminium and lead. If my precipitate disappeared, I would have zinc. I want to show you guys what zinc would look like, just so you know what to kind of expect. So this one is not obviously something I'm going to write down because it's just for you guys to use as reference. And I'm happy if you guys want to have known ions while you're working to be like, can you get me a bottle of zinc? I just want to double check against zinc to make sure that this precipitate is what it is. So here is zinc nitrate. I'm going to squirt it in, about that amount. And in this case, I'm going to add, like I said, the 2 drops of ammonia. And it's really hard to see right now. I'll point it on the document camera, and then I'll also walk around with it. But can you guys see that's a little bit opaque? Okay, good. So do I need to walk around? You guys okay? Ah. So you see how this one is opaque. So same step that I did here. This one, either aluminum or lead, I've added 2 drops, and I got a white precipitate. This one is also white, but it's kind of that more opaque color. So that would be one indication that I know it's potentially zinc. And then what I would do is I would add excess of my ammonia. Oh, making it worse. Okay. You can actually see it a little better now. That opaque. All right, now I'm going to take some of that out because I want to make sure that if it is zinc, will it dissolve if I have the ratios right? So again, we're always playing with our ratios to make sure. So I've just added a little bit out. I'm going to add more ammonia to it and see. It does take quite a bit of ammonia to get it to dissolve. So that's why, it's still not even fully dissolved, but you can see that it's a lot less opaque than when it was over here. Okay? So that's what zinc would look like. So just FYI when you guys are checking. All right, so I've ruled out zinc as a possibility. In my last step then, I'm taking a new sample and I'm adding the sulfuric acid. From that information, I'll be able to figure out if I have aluminium or if I have lead. That makes sense to me because when I look at the rules for sulfates, most sulfates are soluble except calcium sulfate, barium sulfate, and lead sulfate. So that's going to how I distinguish between aluminium and lead. Aluminium wouldn't form a precipitate. So let's add that to our list. We have a new sample. Unknown. And hydrochloric acid. I have just the right number of test tubes. So put my unknown in there. Grab my sulfuric acid. And then we see white precipitate. So I've ruled that this is lead. What you're going to find is that area of white precipitates is a real pain in the butt because white precipitates, there's a lot of them. So from that information, we have determined that the unknown ion is my lead ion, Pb2+. And if you guys want to double check me, that was the unknown bottle. Cool. All right. Now, last thing we need to do for the achieved is every time I see the word precipitate, I need to write down what that precipitate was. So that's quite a bit. Remember when we were talking about these precipitations and trying to figure out what they are, keep in mind what type of ion you've identified. All right, so lead here is a cation. So I am thinking about the anions that got mixed in with the solution. Are we okay with that so far? All right. So cations. So in this case, if I'm thinking about what precipitate formed, all of these precipitates should have lead as the first option. So I just want to double check where all the ones that say forms are going. Cool? All right. And in fact, we can write down the formula as well. I suggest writing down both the formula and the word equation, sorry, word version of the name just as a backup. in case you make a mistake with the formula ratios. We good? All right. So when I look at my first step here, unknown, and added 2 drops of sodium hydroxide. Sodium is a +1 ion and hydroxide is a -1 ion. So I want to have the hydroxide in this case. We are ignoring cations because we already have identified a cation. So this would be lead hydroxide. Lead hydroxide has a +2 charge, so I need 2 hydroxide ions to make that 0. We good so far? All right. I added excess, it disappeared, but I'm not going to worry about that for the achieved. If you are working towards merit or excellence, we do need to start worrying about what that stuff is. All right, new sample, unknown, and I added 2 drops of ammonia. So this is the tricky thing that a lot of people make mistakes on and thus miss out on their points. Angela, you can grab a sheet like this from the front. We're just working through cations. All right. So something you have to remember that's going to be tricky about this is that we are not using the ammonia in this precipitation reaction. We are thinking about what ammonia is. So ammonia is a weak base. So in this case, since it's a weak base, the anion that I'm going to be using is the hydroxide ion. So that's just a secret thing to kind of remember with this one here. A lot of people get messed up there. Let me write out the equation so you understand where this hydroxide is coming from. So when I add ammonia to water, the ammonia reacts with the water and forms the ammonium ion. And the other thing it forms is the hydroxide. So that's where this hydroxide is coming from. Are we okay with that? So whatever you have for the sodium hydroxide, you're going to have the same thing with this 2 drops of ammonia. So I'm going to write lead hydroxide again. It was the same precipitate, funnily enough. So that's lead hydroxide. If you guys noticed with the zinc did disappear, and that's because a complex ion was forming between the zinc and the with the ammonia. So if we look at our complex ion list, you see how zinc can form a complex ion with ammonia? That's why the zinc one disappeared. If you look at this list, lead is on here, and it forms a complex ion with a hydroxide, but there's not enough hydroxide in this ammonia for it to make the complex ion. So that's why that one there didn't dissolve. So it dissolved up here, but did not dissolve down here. And that's because lead has no complex ion with ammonia. Cool. All right. Last thing then is my sulfuric acid. So in this case, remember the hydrogen ions are positives and the sulfate is S2 minus. If you're not sure, look at the resource sheet because we give you all the ions, we give you the charges. So I would want the sulfate in this case, and I would identify this as lead sulfate. Or formula, in this case, because that's +2 and that's -2, I just have to write SO4. And then we're done. So I'll just zoom out so you guys can see the whole thing. This is the write-up then for the cations to the achieved level. A little bit more work because there's more steps when it comes to identifying cations. But same process that you guys were doing before. I will stop it here for now. I will go over the merit and excellence bit so you guys can have the example of that. But I want to give you guys a chance to do some unknowns and identify them. So I'll put 2 more unknowns up. We'll do unknown number 1, unknown number 2. You guys will then also make your own little box as well for identifying cations. Grab, obviously, some more of these template sheets so you can practice the write-up. Sound good? And then goggles and hair up as well. So let's grab all those things.